Shown here is the distribution of seismicity in Germany indicated using circles. The size of the circle scales with the magnitude, the strength of the quakes. Only magnitude 3 and greater are shown here. We see that the earthquakes in Germany are unevenly distributed. There are areas with clusters of quakes. Here, in the lower Rhine Bay, in the Swabian Jura, in the Vogtland and in the upper Rhine Graben. Some areas in northern Germany experience only low earthquake activity, or even none at all. Hello and welcome. In this video, I will be introducing to you the 4 major earthquake regions in Germany, called seismically active zones. You will become familiar with major earthquakes which represent these zones and how they can be described quantitatively. Furthermore, I will also show you how these events can be summarized in order to create an earthquake hazard map in Germany. This is not only relevant for earthquake hunters planning their next vacation, but also for insurance companies and the compilation of building codes. I will be introducing to you the individual quakes with the location and time, magnitude and intensity. While the magnitude quantifies the strength of the earthquake source, the intensity describes the effect of a quake on people, things and nature, as well as damage on buildings. The intensity scale ranges from 1 to 12. Intensities of 3 are felt by a few people. Minor building damage occurs at intensities of 6. An intensity of 7 describes widespread minor damages, such as cracks in walls and falling plaster. Walls in a poor structural condition collapse. Starting at intensities of 8, people may lose their balance, and simple masonry buildings experience heavy damage, such as the collapsing of gables. Heavy damage results even for solid, reinforced structures at intensities of 9. People begin to panic. An intensity of 10 describes the destruction of a large number of well-built houses and is the largest level assigned so far since the systematic application of macroseismic intensities in the 19th century. The levels 11 and 12 describe the partial and complete destruction of almost all existing structures. In Germany, maximum intensities of 8 were reached in the past. I will now show you where and when. We start our journey in the Swabian Jura. It stretches from the north of the upper Danube Valley from the northwest to the northeast. Geologically, it consists mainly of Jurassic limestone. Only a limited section of the Swabian Jura is seismically active. The core area is located in the Zollernalb region near Albstadt. This is where earthquakes repeatedly occur, which result in damage to buildings. On November 16, 1911, a strong earthquake caused significant damages. Retrospectively, a hypocenter depth of around 10 kilometers and a magnitude of 5.7 was estimated. In some towns within the epicenter area, almost all buildings were damaged. At some churches, gables, walls or steeples collapsed and hundreds of chimneys broke. On average, the earthquake could be felt up to a distance of around 500 kilometers. These extensive damages were rated as being characteristic of a macroseismic intensity of 8. A more recent quake on September 3, 1978 reached intensities of 7 to 8. Significant damage to the building gables can be seen. The second earthquake region I wish to introduce to you is the Vogtland in the border region between Saxony, Thuringia and the Czech Republic. The center is located near the Czech town of Nový Kostel. This region is known for its earthquake swarms. This means that from time to time, a large number of quakes of similar magnitude take place here, clustered both temporally and spatially. Hence, in this case, there is no typical main shock that is framed by smaller after or foreshocks. The magnitudes are often in a range of 3 to 4. Only in isolated cases do they result in damages. Examples include the years 1872 and 1985. On December 21, 1985, a quake reached a magnitude of 4.5 and had an intensity of 7. It was part of an earthquake swarm that began in early December 1985 and lasted until early February 1986. Over 300 quakes with magnitudes greater than 2 were recorded, many of them could be felt locally. The third destination is the southern Upper Rhine Graben, in the border region between Germany, France and Switzerland. Here, the largest known earthquake in Central Europe occurred in 1356 near Basel. Historical records suggest a maximum intensity of 9 and a magnitude of 6.9. Such an intensity means the destruction of most buildings of a simple architectural design and general panic. Due to the resulting fire in the city of Basel, 300 people died. In more recent times, there have repeatedly been quakes in the entire Upper Rhine Graben between Basel and Frankfurt with more minor damages. On average, it is every 60 years that magnitudes of 4.4 or greater occur. Depending on the hypercenter depth, they may cause intensities of around 7. Finally, we will pay a visit to the lower Rhine Bay at the west of Cologne. Major quakes here include the one in Düren in 1756 with an intensity of 8. Or in more recent times, the quake near Roermond in the Netherlands in 1992 with an intensity of 7. The effects of a quake can be amplified due to the unique local geology at a specific site, which is of great importance for the major city of Cologne, for example. Today, the simulation of the entire wave field of an earthquake is possible with the use of high-performance computers. In this example, you see the modeled wave propagation after the 1992 Roermond earthquake. It can clearly be seen that the waves propagate almost unhindered outside the lower Rhine Bay. Within the lower Rhine Bay, however, interference with the reflected waves occurs and leads to high macroseismic intensities. An intensity map of the Roermond quake, calculated based on this, corresponds quite well to the observed intensities. Such simulations help to estimate the hazards posed by future earthquakes. The earthquakes presented were rare major events. If we include weaker ones, we can make estimates regarding the frequency of certain magnitudes. This is done for various earthquake zones, similar to the manner in which I just described. The summary of such studies describes the seismic hazards in Germany. This map shows the earthquake zones in Germany. It indicates a 10% probability of occurrence for macroseismic intensities within 50 years. This corresponds to a mean period of recurrence of 475 years. For example, here in the Swabian Jura. It is assigned the highest earthquake zone 3. This means that on average, an earthquake with an intensity about 7 to 8 occurs once every 475 years. The same hazard level is also found in the southwesternmost corner of Germany to the north of Basel and in the lower Rhine Bay to the west of Cologne. Regions in earthquake zone 2 have the same probability for an intensity about 7. That means half an intensity level lower. This continues until level 0. This hazard map is part of the German DIN 4149 and the European-wide Eurocode 8. Both contain regulations for earthquake-resistant construction. Hence, the higher the assessed seismic hazard, the safer buildings need to be constructed. Furthermore, in addition to the earthquake zones, there are also significance categories. Normal buildings need to be equipped to withstand the intensities which are reached on average every 475 years. You have seen this probability on the map. Schools, on the other hand, need to be able to withstand even less probable events. In this case, the period of recurrence is 825 years, or a 6% probability of occurrence within 50 years. For hospitals, this period is 1,225 years, and nuclear power plants have a very high value of 100,000 years. In this video, you have learned about the major earthquake regions in Germany. The Swabian Jura, the lower Rhine Bay, and the southern Upper Rhine Graben are the areas most affected, and to a lesser extent the Vogtland as well. The knowledge of this hazard comes from earthquake records from seismometers, but also historical written records. Based on a number of examples, you have seen which major effects earthquakes can also have in Germany. In order to prevent the potential dangers, regulations for building codes specify how earthquake-resistant structures need to be.